And we are live. So, good morning, good afternoon, and good evening to all our viewers from around the world. Thank you so much for joining us for this live session. My name is Anish Bhargav, and I'm joined by Ganga Sumant, who is our resident senior security engineer at AppSecEngineer. So, welcome, Ganga, and thanks for joining us.
Thanks a lot, Anish. Thanks for having me over.
So, if you've been seen any of AppSecEngineer's live streams, you'll definitely be familiar with Ganga Sumant. And today he'll be taking us through a live session where he'll be showing us one of the labs associated with threat modeling in AppSec Engineer. So why don't you tell us a little bit more about that, Ganga?
Sure. So, while AppSecEngineer is mostly focused on various avenues of security, like application security, Kubernetes security, so on and so forth, one of the edge pieces that we have is threat modeling, which is more of a system-oriented view of security itself. And the idea here is to try and analyze your application before it is built, before you have ever written a single line of code. We want to break down the application and think from an attacker's perspective to try and understand how the application can be broken and what could potentially go wrong with it. And the end goal of an exercise like that would be to try and mitigate problems before they ever show up. So in today's lab, I'll actually be talking you through the process of threat modeling and talk about what makes it difficult, but also very fulfilling. And I'll also give you a way to make it happen much, much, much faster than it was ever possible before.
So I've heard that threat modeling is really important for companies these days because as applications get more and more complex and teams get larger and larger, you kind of have to consolidate all of that learning and all of that sort of your security program into one sort of singular threat model. So
Mm.
is that kind of like what this is aiming to achieve?
Yeah, that's a very good question. Uh, uh, Perhaps the primary problem today is that, or not a problem, we're actually suffering from success, to be honest. What has happened today is that it has become easier than ever to build applications. And while complex applications are still something that massive teams across the globe are building, security has also started to become something that we can no longer ignore at any cost. However, the problem happens to be that in your agile software development process, security is no longer uh, tightly coupled enough to keep up with the rate that the application is being built. And threat modeling, by definition, is a very exhaustive process in that it involves a lot of different stakeholders to come and meet at the table. However, it again, as with everything, we have now ways to make this threat modeling also happen in the same pace that you're building your application. And if that is possible, you are now able to build your application securely from the very get-go. And in this short webinar, I'll be discussing that idea with you and showing you some ways in which we can get started on that process.
Awesome. That sounds great. I'm really looking forward to seeing what you have here. So
Thank you.
let's start it with that.
Cheers. So, kicking off, let's talk about threat modeling and the idea of threat modeling in minutes. Uh, Primarily speaking, what is a threat model, right? So a threat model is something that encompasses several different parts of your application to the point where we're able to understand the application, break it down into its core fundamentals to understand what the application is made of, why it is working the way it is working, and how it is doing those actions. And once you're able to understand the system that the application is trying to model, then you're able to verify, enumerate, and identify the kind of risks that you can even face in an application of that sort. So your security risks can come in various forms and fashions. And if you've ever done a pen testing or any sort of verification afterwards, you will note that your security risks can come in the form of SSRF attacks. Maybe your application is vulnerable to XSS. Maybe your infrastructure is not hardened, etc., etc. But these are things that you're only finding out after the fact. However, if you were looking at your application, your system from the perspective of somebody who's going to attack it before it is ever being built. So you assume, when you're building a threat model, you assume that the application has already been built, and then you model it from the perspective of a red team attacker. You try to figure out where there could be vulnerabilities in the application that you're building. So for example, let us say this is an on-prem application, and that it is going to be deployed only within your application, your company's VPC. Then you inherently lose a lot of risks associated with that application being open to the internet. So you're more worried about the kind of access controls that your internal employees have. But if that same application is now on the open internet, you're now suddenly worrying about whether it's possible for bots to access this application. Are IP addresses openly visible? Again, your entire perspective on this changes completely. So a threat model allows you to objectively break down the application into all of its components, figure out the kind of data that is important to you within this application, and then you can come up with threat vectors or attack scenarios that would make your application vulnerable in these different formats. And once you have all of those solidified and you have a control on that, then you start listing out various ways in which you can come up with defenses against different varieties of attacks that you've just listed out. And as always, you understand that this is going to be a cyclical process where you figure out an attack vector, you figure out how you can stop that attack from happening, and then you go back and have another discussion to figure out whether you've enumerated all possible attack vectors and whether your countermeasures that you've come up with are good enough to meet those particular attacks. So all in all, a threat model is a document that allows you to model your system's risks. And once those are modeled, you try and build a relation between each attack, attack scenarios, attack vectors, and then you try and find mitigations for each one of those that you've just listed out.
So would you say that a threat model is something
Mhm.
that goes a little bit advanced in a security program, or is it something that you should start off right away?
Yes. So the maturity level in which a threat model comes in, honestly speaking, should always be uh, a threat model should always be present, to be honest. However, you will find out as we walk into the next step of this process is that threat modeling becomes a very difficult task to do, because you not only have to understand the system itself, but also the infrastructure that the system is going to be built upon, and the security risks associated with each piece, each component within that system, which is a very a tall ask. And the problem that I've seen time and time again in all the different places that I've done threat modeling for different systems and for different features is that the knowledge of the system is going to be broken down across the organization. So your cloud engineering team is probably going to have a lot of information about the infrastructure. Your application engineering team is probably going to understand the system itself, and your DevOps team is probably going to understand how that system is going to be deployed onto your network or onto your infrastructure. And the problem for a security engineer is to understand all the places in which the threats can come in, and then to list out a series of countermeasures against a large long list of threats that you can enumerate here. And as you can understand, one person having that amount of understanding is going to be hard to come by. But also, when a large amount of features are being shipped on a weekly basis, it becomes nigh impossible for one person to ever keep up with this kind of output. So
Right.
yeah.
That makes sense. Yeah.
Hmm. So I think we've discussed this a little bit, but let's break it down properly. So why do threat modeling? Threat modeling, as I've just been describing, is a process you should be doing even ever before writing a single line of code. So oftentimes it goes hand in hand with your architecture, the application architectures being built. At the very same time, you should be doing a threat modeling process. In often cases, you'll find that threat modeling is also called a security architecture review. And while the review word makes it sound like it is something you do after the architecture has already been built, but in fact it is more of a hand in hand process where your application architecture includes your security architecture, and the security architecture again gives feedback to how you're designing the system itself. And the result of this is that you get the ultimate shift left. It means that ever before building, you can completely eradicate several types of risks entirely. So if you're talking about XSS, if you're talking about CSRF, things like this, if you know that they are probable, threat scenarios for your application, you can bake those into your application architecture just at the time of building itself. And it allows you to prioritize security issues and your remediation activities. And the reason for this being, you will often find that if you were to write down an exhaustive list of all threat scenarios that can affect your application, you will find there are going to be several types and kinds of problems, depending on where you're hosting it, depending on the kind of application that you have, depending on the users that you're expecting. All of these are just going to compound and give you lots and lots and lots of threat scenarios. And again, oftentimes, the best way to showcase this kind of volume is when you look at your pen test report, you will have hundreds of low findings and maybe a few tens or dozens of mediums and a few highs and criticals. And honestly, those highs and criticals are the ones that actually make or break your application. Those lows are probably something that can be patched quite easily if you have a proper DevSecOps process, which is continuously like scanning for threats, scanning for third-party libraries that have been compromised, and then you have patches coming in. So threat modeling from the get-go allows you to understand that even the pen testing results that you get in the end, you have a very steady, you have a focused vision on what is important for your application. And this kind of knowledge allows not just your security engineers, but also your software developers to understand where threats can come from and how to fix them before they ever happen. And the next point is what I was just describing. The threat modeling process becomes something inherent to your quality assurance program. And because your threat model already dictates that there are certain pieces of the application that are more vulnerable than the others. Again, vulnerable could possibly mean that you have business logic, or you have customer sensitive data, or you have financial transactions happening. If there are pieces of your application that have more information than the rest of the application does, then any piece, then any network intrusion or any malicious actors acting in that domain, in that specific area, become further focuses for your assurance department to take a look at. And finally, this is being mandated by several different organizations right now. In fact, NIST has a very particular compliance regulation that is aimed at threat modeling. It asks that every application submit to a threat modeling process, and that this is documented, and it is available for every vendor downstream for them to review and then accept. If your threat modeling process is correct, then your application is correct, and therefore they have a degree of confidence that your application is secure.
Yeah, in fact, in our in AppSecEngineer, we focus a lot on compliance because that's become such an important part, especially of like software development across EU, across the US, pretty much everywhere in the world. Compliance really can make or break a company because if you are
Hmm.
not really adhering to the certain laws or guidelines of your location,
Region.
that
Hmm.
could that could absolutely be pretty devastating for your business.
Yeah. In fact, your business will not be allowed to operate if you are not compliant with the regulations of your particular region that you're serving. In fact, I see this quite often, especially with GDPR regulations that ask that the data being processed never leave the confines of a certain region. Um, in fact, just to comment on this a little bit, I was recently dealing with an organization that wanted to use captcha, your Turing tests that you have, where you fill out the numbers and such. The data that was being processed for the captcha was not supposed to leave Germany.
Hmm.
However, the most common and famous captcha that you see is that Google's reCAPTCHA, where it makes you click on
Hmm.
different images.
Right.
That data is not processed in the EU. It is processed in America.
Oh my God.
And the German laws were strict enough to say that it is okay for your application to be DDoSed and completely unavailable, but it is not okay for your application to process data in a different country. So
That's
the
wild.
regulations are changing. Yeah, yeah,
Yeah, because it's like, I mean, who would even think of that, right? Like, that's not something that comes to your mind immediately.
absolutely,
Yeah.
absolutely. So let's talk about the core fundamentals that drive a threat modeling process, and then we will get into one example. So the very first question is as simple as it sounds. The question is, what are we building? And this allows you to frame a lot of the responses to your threat model. In fact, I find that the best way a threat model works is if your entire framework is a series of questions where you're asking maybe yourself, or maybe you're asking the software developers, the business executives. It doesn't matter. Different questions allow you to build a much better model of the application that you're trying to achieve, and therefore you can protect it better. And this what are we building question allows you to frame the context for what this application is going to be doing, where it is going to be doing that, and who it is going to be serving. And once you answer those questions, you suddenly understand. Yeah, um it enriches your understanding of the application, and therefore your security context becomes much deeper. And this leads in quite easily to the next question: what can go wrong? If you understand the application, you can then ask what can potentially go wrong at different points. So in the threat modeling language, we call these trust zones or trust boundaries, where we define certain pieces of the application to be uh, much better removed from other parts of the application. So for example, if you have a web page that is processing some user forms, the point of contact with the outside world, with the internet itself, becomes those forms being exposed to the internet. So that is going to be your least amount of trust. And that becomes the point where most things can possibly go wrong. As you come deeper into the application, you can then start asking questions of, so what if somebody who's not supposed to have access to the form management platform gets access? What happens then? Or what happens when all the forms that are supposed to be automatically processed are not processed anymore? Something happens, maybe the application breaks down, maybe the infrastructure goes bad. And then you can start figuring out what to do in those circumstances. You can build redundancy, you can figure out what sort of SLAs you want to keep, etc., etc.
It's literally like building a fire drill for your application. It's like a,
that
contingency plan for everything.
that is absolutely one of the best analogies I've ever heard. And that is exactly what a threat model is. It is ensuring that you understand the building well enough so that your fire drill actually does what it's supposed to do. That was splendid. And the final question is something that I keep seeing that most people don't pay enough attention to, and understandably so. The threat modeling process is exhaustive. It asks a lot of people to come to the table to give their inputs, and it sometimes drags on for weeks at end because that information is not readily available. The questions that we will get into very shortly, you see, are something that would involve business executives who probably have a very large overview on the application and what it's supposed to do. The software developers who are trying to interact with the architects who are trying to build something else, and the security engineers who have certain gates that they will not let the application pass through. So getting everybody into into the room and understanding and accepting what needs to happen, it's a hard process. But it also means that you're not doing threat modeling as often as you should. And that can often lead to quite disastrous results, in that you have very outdated versions of your application on the books, but your application has far outstripped that in reality. So at this point, let's quickly jump into an example and then we can discuss that. So here, okay. So this example is something that I will be showcasing a lab as well. But the idea here is that I want to show you a very simple application. This application's architecture diagram that you're seeing here is essentially something that it's called Acme Events, and this application allows larger organizations to send out forms and reviews to their users. So let us say you are a large organization. Let's say you're IBM, and you have thousands of employees who you want to bring into either marketing or some sort of like some loop. You want to like you want to create an event that all of them can attend, and you want to make sure that the people attending are your employees and they are registered in some fashion. So this application allows two different types of users, either end users or enterprise users, to register themselves to the application. And once they do, they are handed off to a payment gateway that collects their information, their credit card data, and that information is then something that the application uses to verify that the registration has happened, and therefore giving them access to whatever event that the organization wants to conduct. So you will see that one major thing here is that the the threat modeling process is going to be limited only to the user registration system. And the reason I'm bringing this up is because defining the scope of often defining the scope of a threat model often becomes the most challenging part, because if your scope is not defined at the get-go, and trust me, it never is, if you do not define the scope, you will end up pulling more and more people into the process, and it will never get over. But at the same time, if you do not have enough depth that actually addresses the application itself, then your security results are not going to be as, there's not enough depth to actually use. So in this case, the scope is going to be limited only to user registration. Obviously, this is an event organization, and there are probably going to be other application pieces that we're not seeing here. And there is probably some way to live stream, there is probably some way to collect reactions, maybe some commenting, maybe some, again, a lot of things that we are not focusing on right now. The only point here is that you have a user registration workflow that is talking to a Next.js front end that is hosted on an AWS Amplify service, and we have GraphQL that is allowing these the GraphQL is a REST API service that allows you to declaratively talk to the core API, the reporting service, and which in turn will talk to your database that is collating all the information about who is registered, whether they've paid, when this happened, etc. So uh, to walk you through the process of threat modeling, let us take this application, and I will do the process manually, like I've already done it here. So for the sake of the webinar, I've gone ahead and manually written down how I would threat model this process. So I would define the application itself. So I would break down the application. I would say what this application is meant to do, who it is serving, why it is doing it the way it is, and the tech stack that is involved in the process. So in my case, you will see that Acme Events is a leading corporate events management platform, and they manage large amounts of events, from virtual events to physical to etc. etc. And the enterprise users are allowed to set up forms. So your enterprise user sets up the form, and the end users are the ones that are subscribing to these forms, filling out their details, and then Acme Events is collecting the registration information as well as the payment transaction information. So for the eagle-eyed amongst you, you will probably notice that the payment gateway is probably one place that you would have to pay the most amount of attention to. And if you have enterprise users, then you also probably have to ensure that their identity is secure and it is verifiable. So in both circumstances, the application makes it quite easy for us because we have some sort of a payment gateway, and therefore we don't have to worry too much about how the credit card information is being stored and where it is being collected from, etc. And in case of the identity itself, we have Azure Active ID. And this is an OIDC that allows your enterprise users to connect to the application. And therefore, we have a secure line for verifying who these enterprise users are. And therefore, those forms that they're setting up can be traced back to them, and we can reasonably be sure that they are secure. And as far as the tech stack goes, like I said, it's an Apollo GraphQL server that is the core API is authored in Java, and the API for user registration service is a legacy service. So we might have to take a look at what that legacy API is going to be. And we have OIDC. So by and large, this is the architecture of the application, and we're trying and figure out where the application talks to external entities and where data is flowing through the application that could potentially be bad. So external dependencies that we found were the Azure Active Directory and the payment gateway. Most else is being either hosted by the application owner, so Acme Events, or it is being hosted on some cloud infrastructure that they have rented out. Now, the very first question that we are talking about, which is, what is this application? What are we trying to build here? And that question is encompassed by this security objectives idea, which allows you to uh, take the business users perspective, which asks the questions: what could potentially go wrong, and what does the business care about? So in my case, I was sure that the confidentiality of the customer, so you have lots of customers signing up, and therefore all of that registration information is going to contain some information, probably names, addresses, maybe some version of their employee IDs, something that can trace it back and ensure that this customer is who they say they are. But as the processor of this information, I should ensure that this is not being leaked and something is not going wrong there. So the confidentiality of user PI, number one responsibility. So number two would be compliance. Again, because I am taking payment card information, I am taking PII. So I could be, and if it's for a hospital organization, the workers of the hospital would then ask that I have HIPAA compliance. The data residency would mean GDPR, or um, and in case of the payment industries, so the PCI DSS could also apply to me in some fashion. So all in all, compliance becomes a very major thing. Third is availability. Again, the reason that large organizations are using Acme events is to ensure that all of their customers and all of their users are able to sign up as in a easy to do fashion. And to do that, my application should always be running. And because I am open to a large amount of audience, I should also ensure that I'm not vulnerable to DDoS attacks. And fourth, integrity of transactions. Because I'm processing registration information, it is important that all the records that I hold are not suspect. And finally, abuse prevention sort of goes back to availability. Perhaps it is very similar, but we will talk about abuse prevention in a way that DDoS attacks um, are not bringing down the application.
Just one sec. How can you be sure
Yeah.
that like your security objectives are like really comprehensive? Like, because I mean there can be an endless number of objectives. So how can you be sure that what you have chosen as your objectives are the
Yeah, that's a good question. And that takes me back to the fourth question that we had when we started the threat modeling process. The fourth one, if you remember, was, did we do a good enough job of what we were trying to achieve?
Mhm.
And the reason I bring that up is because threat modeling, as you're saying right now, is something that I'm going through on my own. However, in the real world, you'll often find that there are multiple people at the table, and we are asking these questions. The security objectives are what security asks of the business management, of the security architects, of the application architects.
Mhm.
And these are high level directives that we sort of start off of.
Okay.
At the same time, you will notice that there is a bit of the language here is not hard to it's almost standardized. So
Yeah.
compliance, availability, integrity, these are the core tenets of security.
Yeah, the pretty
And
broad terms.
yeah, so it doesn't really go too far. You are essentially just going through a checklist of what security normally tries to do, and then
Mm-hmm.
try to find out how it applies to your application.
All right. Fair enough.
And obviously in the back and forth you get more and
I
more
guess it would also
information.
be iterative, so it's constantly improving.
Exactly. And in this case, there are a few objectives that, again, this is not an exhaustive list for a reason, because this application does not need everything that's out there. So for example, I don't actually have authenticity here,
Mm-hmm.
because I know that the application users are using OIDC, and therefore I have offloaded that task to Azure, and I no longer have to do that.
Fair enough.
Yeah. Now that that piece is done, we again go back into the details of the application, which is to figure out what components are being used. And this is essentially just a list. It is talking about what component is doing what and how it does what it does. um, Having this list allows you to break down each component and figure out what sort of network accesses it could have, what could potentially go wrong with the way it is communicating with other components. This is a high level view of your application that you can break down again. But the most important bit actually is the data dictionary. And the data dictionary allows you to figure out what information flows through your application that is important to the business. And in our case, again, from the security objectives, circling back, we realize that we have PII in terms of two things. We have Acme events, the customer PII flowing through the information through the application, and this could potentially be names, emails, addresses, anything that could be leaked would essentially mean that that customer's information is now widely available. And because we are the data processors, we could be essentially like leaking tens of thousands, if not hundreds of thousands of customer identifiable data, and therefore it becomes one of the most important things that we have to protect. And in the second case, we have PCI data, which would be card information, probably some sort of name and maybe the last four digits, because as an application user who has used a payment gateway, we are probably holding on to transaction IDs. We are probably holding on to maybe the four digits, maybe the name of the user, which puts us lower on the scale of what sort of data we are handling, but still something that we should be careful about. And finally, customer registration assets, which could be um, the kind of event, where it is happening, how many people are invited, when. All of this information is going to be in sorts of static websites, or maybe some sort of form that they're filling out. If that were leaked, again, this would be customer sensitive data that we should be protecting. And the reason a data dictionary is important is because now we are able to draw sort of boundaries around our application data and figure out any time an application component is making contact with this data, we know that that component has to be thoroughly examined, and to figure out that every sort of transaction happening through it is given a lot more importance. And that finally brings us to something called stepping stones. And the idea for a stepping stone is that uh, these are pieces of information, either credentials, either configuration strings, security fundamentals that will allow a malicious actor to gain access to something much bigger than what is within itself. So for example, the database contains RPII. So it has our customer information, it probably has transaction data. To get access to the database, you have to use passwords or connection strings. So anybody who has access to passwords, it could be authorized database administrators, it could be maybe some sort of you have a deployment engine. So maybe your CI/CD pipeline has these connection strings that are embedded into them. All of these now become suspect, and we are trying to ensure that those pieces are also secure. If the keys are locked away, then you can be sure that the lock is actually going to work the way it is supposed to work. So we essentially use stepping stones as a way to go back and look at our application and figure out where things could go wrong, and therefore what is one or two steps removed from that that could give you access to the major piece itself. And that gives us this list. It's the database. We have AWS Cloud, which could have access tokens. The payment gateway could have configuration secrets. Your Azure IDP, the application that you're putting up, it generates OIDC tokens and access, refresh, and auth tokens. If those are compromised, you'll have issues. The Azure AD, the Active Directory, will have SSO secrets. Any of these, if they are not securely stored, you have issues with the component itself that is integrated into your application. So this is part one of the threat modeling process. This is us defining the system in a way that allows us to start figuring out where threats can come from and where threat scenarios can develop from. So for the purposes of this webinar, I will be cutting it off here in the threat modeling process, and I will showcase how we can do this process, which, by the way, took me about 30 to 40 minutes to figure out everything on this page. going from a blank architecture diagram all the way to figuring out the stepping stones. Let us think about a way to do this much faster using LLMs. So for this, let me just switch here. Curse. Okay. So you will notice, just to quickly to explain what I have here, is an interface that I wrote to allow us to talk to an LLM. And what I'm feeding the LLM is just a series of prompts. So in the very first step, I've given it the component diagram that we had started off with, the architecture diagram. And we use a vision model to ensure that it understands the application that we're working with and what to do with it. So the what to do with it part is now divided into two pieces. We have a system.md file. This is essentially a system prompt that uses a certain style of prompting. So this is called ISO, identity and purpose, steps, and output instructions. You will notice that we'll have that information in we also teach a boot camp on the threat modeling process itself and how to integrate LLMs into the process. And the reason why that's important is because you will notice how quickly this can give you the low hanging fruits and fill out the details that you need from this process. So what I've done is to ensure that the LLM understands that it takes on the persona of a security architect who's been given a diagram, and they need to break down the components and figure out the first few steps that we've done in the manual process. So the steps to do so are just illustrated here. Examine the diagram in detail, extract the components, and then identify what other components are connected to and how they're connected to each other. That would be to ensure that it pays specific attention to the kind of process. So we have HTTPS connections everywhere, but the core API is using HTTP to make its final connection. So those are going to be details that the LLM has to pay more attention to. And finally, we ask it to output a data dictionary, a component dictionary, and the security objectives that were derived from this process. So let me just quickly run this to show you how it works. You'll notice that the LLM has vision mode activated, and it is essentially just picking up the diagram that I gave it, and it is running through the ISO prompt to generate an output file. Let me show you the output file as well. Okay, it's been created. User.md tells it essentially gives the LLM the context of the application. So system was telling it the purpose. It was setting up the order of steps that had to be taken, while user.md gives it information about the application itself, the tech stack that was involved, and finally the diagram that we were working off of. All of this now leads to the output.md file. And let me just make this slightly nicer to look at. There you go. So very quickly, we're able to generate the data dictionary, the component dictionary, and as well as the security objectives that we would have to focus on. So let's do a quick study of whether this is accurate or otherwise. So you will notice in terms of security objectives, let us start with the security objectives and then we can go back to the list of components. The security objectives would be data protection because you have both PII and payment information, exactly what I had noted down. The access control would have to be something interesting. We did not take account of this, but essentially, I would say this is not a great security objective only because we already have OIDC and AD, and therefore, access control is kind of taken care of. But okay, I will give this. Maybe access control is something we should pay more attention to. However, as the enterprise users can only essentially create events and then deal with them, the RBAC becomes less of an issue. However, good thing to note. Authentication. Ensure robust authentication mechanisms in place, leveraging Active Directory. I think this is definitely a miss because we already have AD in place and OIDC is being leveraged. Therefore, authentication becomes less of a security objective and more of a design virtue already that we have in place. Integrity. So to ensure that we have registration and payment data, these transactions are valid and that the users can believe in them. audit and monitoring, establish logging and monitoring systems to detect and respond to any unauthorized access and anomalies. Um, in large part, this is going to be something that is being palmed off to the to AWS or Azure in this case. However, it is a good thing to keep in mind. Perhaps we should talk about maybe using CloudWatch alarms, or maybe having Azure monitor run some system checks that ensure that the correct users are being able to access our platform or otherwise. And finally, compliance, which we also made note of, adhere to both GDPR and PCI DSS in our case, and not much else. With that in mind, you can go back and take a look at the component dictionary. So we have the components. End users are not exactly components, but okay. The event registration, cool. The payment gateway, that is a third-party service. This is correct. The Next.js application using AWS Amplify. This is a front-end application for enterprise users. We have the same thing again for normal end users. The GraphQL service that is doing the API service handling. The core API that is actually doing that talks to the databases, that talks to the reporting, etc. CouchDB, that is going to be storing our user registration information and event information. And the static pages that are being stored in AWS S3, all good. The reporting system that is used for generating reports, and this is something again that talks to the GraphQL service, correct. And finally, Azure Active Directory, which is using OIDC, and this is providing user authentication and control. This is great. And you will see that it also notes down what each component is connected to. So the payment gateway is connected to the registration system. The CouchDB is connected to the core API. Registration page is connected to core API. Reporting system also core API. I think that is quite accurate. Yeah, so the server, registration page, the CouchDB, but the reporting service does not connect to core API, but it actually connects to the GraphQL service. So you'll notice that that was something that it missed on. Let me just make sure it's there. Yeah, not connected to the core API. So you will see that the LLM obviously has it does quite a lot of the work for you, in that it is able to identify the low hanging fruit and give you the information that you need to quickly get started. However, it is always important to have a human in the loop, because hallucinations are very possible and misinformation can spread quite quickly. And it becomes explicitly important at this point, because the more amount of garbage input you give at this point of the threat modeling process, the worse off your results will be at every subsequent stage. So ensuring that it has the correct information here is quite important. And finally, the data dictionary that it has come up with is it's talking about user PII, payment information, registration information, and reporting data. I would probably put reporting data as not that much of a priority, but aggregated data for reporting purposes, likely containing analysis of registration and payments. Yeah, I suppose this can also be something that you can take into account. However, I would be less inclined to include this. But yeah, by and large, this is the first step in the threat modeling cycle, where you ask ask the question, what are we building? And this is the answer to what are we building. We are building an application interface that allows users to generate and to generate events, and other end users to register with them and figure out and then give them payment information, register, and get successful sign in confirmations. And this becomes the first step to the threat modeling process, at which point we can start asking questions about what could potentially go wrong. What happens if user PII is leaked, and how can it possibly be leaked? What happens if payment information is leaked, or what if payment information is stolen? What happens then? And what if the registration information is suspect? What if it doesn't actually reflect the correct state of somebody having paid or otherwise? And these allow us to inform the threat modeling process going forward, and figure out where we need to apply security controls or mitigations as and when they are identified.
It's pretty interesting to see how quickly the LLM has just been able to summarize all, because I mean that's kind of what LLMs are good at, right? That they're able to view a lot of data, analyze it, summarize it really quickly. I think that can be a big help when it comes to threat modeling. Although, of course, you do have to be careful with the managing how it reads all that data and then the output as well. So,
Absolutely right on that end. So the GPTs, right, the transformer models are
mm,
uh, their core purpose, or perhaps their strongest suit, is to be able to absorb lots and lots of language, of written media, and then be able to search through it, to form connections through it, and actually understand that text. So this is something that I've again, something that happened quite recently with me, was that I was provided a 1,000 page user manual for
phew.
an application that we were reviewing. 1,000 pages. And from a security perspective, there's absolutely no way I could have read 1,000 pages. It's just not happening.
Yeah.
And I was able to quickly give it to an LLM, ask it to summarize the important pieces that I wanted to think about, and then go back to the manual and start looking at those sections in detail.
Right.
Obviously, I will get a lot more understanding of it if I were to read the whole thing, but the absolute fatigue that I would have if I were to read through all of it, like the amount of time it would take me, is just unbelievable. So in that perspective, I believe LLMs are quite well married to the threat modeling process, in that they're
Hmm.
able to crunch through quite a bit of information. And oftentimes you'll find that your application is now several generations old. You have probably already made quite a bunch of tweaks. A lot of features have been added on, and it is like a house that has been built in
Hmm.
an ad hoc fashion. And in such circumstances, being able to draw lines of connection between different parts of the application becomes especially important.
Hmm.
And LLM can make that process quite easy, quite fast. And I think it now allows you to actually do threat modeling at the head of every sprint.
Hmm.
And you can actually do threat modeling in the agile process, which was never possible before.
Nice. So this lab is essentially a part of this of our threat modeling boot camp that you will be hosting, isn't that right?
Exactly. So, as you can tell, we were only focusing on the very first section of the threat modeling process. There are several more to come. And all of that is going to be packaged into a single threat modeling bootcamp that lasts over 4 days, I think around 3 hours each, where we break down the threat modeling process, allow you to understand how it is supposed to work, and where it is supposed to be applied. But more importantly, we give you the tools to use an LLM to make that process much faster and much more repeatable. So that involves teaching you how to write the prompts, to fine tune the language to figure out how to always get repeatable results, and also to give you a framework so that your threat modeling outputs and results look similar from each generation to generation. So every agile sprint that you go through, you will have something dependable that you can keep coming back to, and therefore you can have discussions with your team that actually needs to take a look at this.
That sounds amazing. So, I mean, I think this boot camp is going to be running multiple times, and you'll be able to get the details on our website, appsecengineer.com, and of course,
Mhm,
probably on the live as well, on this live session.
mhm.
So, look forward to that. I'm sure you'll be able to learn a lot about threat modeling, and I think this is the next frontier of the threat modeling and security, especially because LLMs are getting involved, and you're really going at breakneck speed when it comes to
Yeah.
development. So and Ganga Sumant will be taking that class, and as you can see, he's at the forefront of threat modeling design and all of that. So you can expect that to be coming very soon. So look forward to that.
Thanks for the kind words, and hope to see you there.
Yeah, see you there. Get registered as soon as the dates are available, and we'll see you there. Thank you.
Bye bye.